Algebra 1. So today we are going to be reviewing for a quiz that you will have on Friday. So we will spend 2 days reviewing for your quiz, and we will be using the same format that we did the past 2 days. So today we'll do your Unit 10 Day 7 notes together. Again, this is in your green packet, and what you'll submit to me today is a Canvas quiz, and then tomorrow we'll go ahead and we'll do worksheet 6 together. You might have a few problems that you have to complete yourself, and that's what you'll submit, and you won't have a Canvas quiz tomorrow. Okay, but today we'll do notes together, and then you'll submit a Canvas quiz for me. And then Friday you'll have your real quiz. So let's begin by going over zero product property. This is something new that we introduced this week. Zero product property is used to solve equations that are in factored form. So again, factored form looks like FOIL. So one thing that people want to do frequently is they're so used to foiling that they want to go ahead and do this. You don't want to do that though, because it doesn't say to multiply. It says to solve. So to solve using ZPP, we just go ahead and we set each piece that has an x equal to 0. And then we'll use our inverse operations to solve this. So for example, here I have a minus 5, so I'll add 5 over. And then I have 2 times x, so I'll divide by 2 to solve it. And you'll just get x equals 5 over 2. Or if you want to say 2.5, that's fine. That's what you get when you divide it. All right, and then this guy, because this is just a 1 in front, this is when we can just use our opposites. And you'll see that your answer is just x equals 3. All right, and the key idea here is that these numbers are representing your zeros or your x-intercepts. Okay, so one would be at 5 0 and one would be at 3 0. Okay? All right, let's give number 2 a try. We're going to solve this as well. Really quickly, I'm just going to add a 2x to this problem here. If we had a 2x out front, we would need to set that equal to 0 as well. So I'm just kind of changing this problem on the fly. So everything gets set equal to 0. And I know to do this because my directions say to solve using zero product property. Okay, so this process that I'm using right now is called zero product property. I like to go ahead and set everything equal to 0 first, and then I'll solve. Divide by 2. 0 divided by 2 is 0. Subtract my 2. It's a minus 2. Divide by 8. Okay, and be careful. Negative 2 over 8 is not 4, it's negative 1/4. All right, and then x plus 5. I'm just going to minus my 5, and I'll get x equals negative 5. All right, so that is solving. And again, these would represent our x-intercepts. And just a quick comment, you're going to notice a parabola can't have 3 x-intercepts. That means this isn't a parabola. Okay, this would actually be a cubic equation, and it would look something like, oops, that wasn't a good picture at all. It would look something like this, where you'd have an x-intercept at 0, at negative 1/4, and negative 5. Okay, and that's not a super accurate picture, but notice it's not a parabola. It's kind of more like a squiggle. Okay, you'll learn more about those when you are a junior in Algebra 2. All right, so that's solving using ZPP. Now we're going to factor, and we're going to run through, we might skip that last row. Let's see how long this takes. So factoring is when you do your box problem. Notice there is not an equal 0 at all, so I am not going to solve it. Okay, instead I am just doing my box problem, which is where I have my parentheses here. And all of these are x's, so I can just go ahead and put my x's there. Okay, so we are multiplying in number 3. We're multiplying to 16, and we are adding to negative 10. All right, so remember, when you're multiplying to a positive number, you either have 2 positives or 2 negatives. Since we're adding to a negative, they will both be negatives, and those numbers will be 8 and 2. Do not solve this. Okay, this is done. You were not asked to solve, you were asked to factor. So this is factoring. Do not set it equal to 0. Do not tell me x equals 8 and x equals 2. Nope, nope, nope. You only do that when there's an equal 0. Okay, so only this step. Next, multiplies to 42, adds to 16. Or sorry, 13. I was focused on my 16 from over here. So multiplying to a positive again. See how we're adding to a positive? That means this time I have two positives. And those numbers are going to be 6 and 7. 6 times 7 is 42. 6 plus 7 is 13. Okay. When you multiply to a negative, like here we're multiplying to negative 11, that means you're going to have 1 plus and 1 minus, and it doesn't matter which order they go in. Okay? What does matter is which number is positive and which number is negative. So the numbers that multiply to 11, well, there are only two numbers, 11 and 1. One of them has to be negative, so check. We want a positive 10 here. That means the 1 is the negative 1. Okay, so the 1 goes with the negative, and the 10 goes with the positive. Or I'm sorry, the 11 goes with the positive. And again, the order doesn't matter as long as your 11 is the positive and the 1 is the negative. All right, good. Very colorful here. Let's go on to here. This is kind of our special case. This is called difference of squares. If you'd like, you can rewrite it with a plus 0x. It's because we don't have an x in this problem. What this means is that you are multiplying to negative 25 still, but what you're adding to is a 0. And what that really tells you is that you're dealing with opposites. Okay, so the numbers that multiply to negative 25 and add to 0 are just a positive 5 and a negative 5. Okay, and you can put those in whatever order you want. Okay. Multiplies to 36, adds to negative 12. I'm going to set this up while you think about those numbers. So those numbers should be a negative 6 and a negative 6. And you can leave it like this, or as we've talked about, since these are the same thing, we can write this as an x minus 6 squared. Either answer is acceptable. Okay. All right, number 9. Multiplies to negative 63, adds to negative 2. So 63, when we're multiplying to that, usually we're dealing with a 9 and a 7. Not always, but most of the time. And then since this is a negative 2, that means the 9, the bigger number, is the negative. Okay, so I'll have x minus 9 and x plus 7. All right, let's run through these last three before we move on to solving again. Multiplies to 24, adds to negative 11. Okay, again, I'm multiplying to a positive. That tells me my signs are the same. I'm adding to a negative, so they both have to be negatives. And this should be not 6 and 4, because 6 plus 4 is 10, but 8 and 3. 8 plus 3 is 11. This one, look, see, it's still a 24. Multiplying to 24, adding to a positive this time. All right, so both of your numbers will be a positive. This will be 6 and 4, because 6 plus 4 is 10. All right, and then last one in this section, this is our difference of squares problem again, just like number 4. So since you don't have an x value in here, we are we are adding to 0. So multiplying to negative 64, adding to 0. And this will always happen with perfect squares. Okay, difference of squares, you'll notice that 25 and 64 are both perfect squares. Okay, so that's going to be an x plus 8 and an x minus 8. And there you go. So again, what we did here, all of this is called factoring. Okay, skip those guys, come on to the back. Next, we're going to factor and solve using zero product property. So this is when we take the, both things we did on the first page and we combine them together into the same problem. Okay, so the first step is the factoring step. That's the box problem. So you'll set this up. I'm going to put my x's. Notice now we have an equals 0. So that will come down. I'm going to do my box problem. Multiplies to 40, adds to 13. Those numbers are both going to be positives because we're multiplying to a positive and we're adding to a positive, and it should be 8 and 5. Okay, so that's the factor step. Now we will solve it. So to solve, we set each piece equal to 0. And then we'll use our inverse operations. I'm going to subtract 8. I'll get x equals negative 8. I'm going to subtract 5. X equals negative 5. And again, what you should notice is your factor is the opposite of your solution, or your solution is the opposite of the factor. Okay? All right, number 14. Number 14 is an issue because we don't have an equals 0. We must have an equals 0 because we're using the zero product property to solve. Okay, you have to have an equals 0. So we will have to add this 20 over first. See how it's just the regular number? That's like your C value from quadratic formula. So it will go last. Okay, we always go x squared x and then our number. And once you add that 20 over, now you have your equals 0. Okay, so that was just kind of a first step we had to do. Now we'll do our factor step. So factoring is where you're doing your reverse FOIL. Put your parentheses with your x's. Make sure you bring down your equals 0. We are multiplying to 20. We are adding to negative 12. I'm going to have a positive and a negative, or I'm sorry, I'm going to have two negatives. I lied. Okay, I'm going to have two negatives because I'm multiplying to a positive and I'm adding to a negative. And that should be 10 and 2. Okay, because negative 10 plus negative 2 is negative 12. That was my factoring step. Okay, so this is factoring. Now I'm going to do the solving part, zero product property. To do that, I just set each piece equal to 0. Okay, and then I can add my 10. X equals 10. I can add my 2. X equals 2. All right, two more. X squared minus 16 equals 0. Okay, good. I have an equals 0. That means I don't need to move anything. I can go straight to my factoring step. Okay, and this is my setup here. I am multiplying to negative 16, and since there is a 0x in there, I am adding to 0, multiplying to negative 16, adding to 0, and that's going to be a plus 4 and a minus 4. And now I'm going to go ahead and solve. Okay, subtract. So x equals negative 4. And add. X equals positive 4. And again, just to reconfirm or to retell you what this actually means, if you were to graph that parabola, it would look something like this, and your zeros or your x-intercepts would be 1 at 4 and 1 at negative 4. Okay, so really this is just doing the same thing as quadratic formula, it's just a lot faster, okay, or solving by graphing. All right, last one of these, x squared plus 25 equals 10x. Oh no, we have this 10x on the wrong side, so I will have to move that over. And so in order to move it, I will subtract it. Now notice it is the x value, so that's different than what happened in 14. Since this is the x value, it's going to go in the middle. So once I move that, I should have x squared minus 10x plus 25 equals 0. Okay, so that's just kind of a first step we have to do. Now we'll factor, multiplies to 25, and adds to negative 10, and that will be a negative 5 and a negative 5. Okay, x minus 5 equals 0. Now you may notice these are the exact same thing. So since they're the same, you don't have to set both of them equal to 0. I mean, you can if you want to, I guess. But when you solve it, you're just going to get the same thing for both of them, right? You're just going to get x equals 5. So you don't need to tell me that x equals 5 twice. Like, it's just x equals 5. What that means is that your parabola only hits once, and it's at 5, 0. Okay? So you really just have to set one of them equal to 5, or excuse me, equal to 0 if there's only going to be one answer. So then the very last thing here, how do you know when to solve using ZPP or just leave your answer in factored form? And the big answer here is you are not solving unless there is an equal 0. So you solve using ZPP if there is an equal 0. And now there are obviously special cases, like for example, number 16, it was equals 10x. So we had to move that 10x over and then there's an equals 0. Okay, so if there's an equal sign, I should say, but you can't use it until it's equal to 0. All right, nice job. So you are done with this. You're going to go take your Canvas quiz, and then tomorrow we are going to work on worksheet 6 together. Okay, again, you do not have to do worksheet 6 tonight. You're going to go do your Canvas quiz, and that is it. Have a great day. Bye.